Alrighty, I'm going to go ahead and get started. Thank you so much for joining us today. This is a webinar on unlocking agentic AI with MCP, and we're really excited to talk about MCP and agentic AI with y'all today. So I'm Julia Martins. I work on the product go-to-market team here at Anyscale, and I'll be joined by Kunling, who's our LLM and Gen AI architect. If you don't see him on the call, it's because his internet is having some issues, but he will be on shortly. And he has so much to add and offer, so I'm really excited for him to join. Quick agenda recap for today. Today's goal is really straightforward. We're going to introduce you to the concept of model context protocol. MCP is a standardized way to connect LLMs to external tools, APIs, and services to unlock like true, genuine agentic behavior. Before we get into kind of the nitty gritty of MCP, we're going to start by tracing the evolution from basic LLMs to RAGs to how we got to where we are today with agents, and kind of show you why MCP is emerging as the infrastructure for any serious AI system. Then Kunling will go through some technical details about implementing MCP, including transport protocols, a quick demo, and an overview of how to integrate MCP with local apps. I'm really excited about that. But starting with, how do we get here? Why MCP? Why are we talking about this today? MCP is a way to connect LLMs to external tools and unlock real agentic behavior. But to understand how we got here and why agentic behavior in general is so important, we kind of need to go back to the beginning where it all began with the LLM boom in late 2022. So as we all remember, late 2022 changed basically everything. ChatGPT launch showed the world that what large language models could do. Then we got GPT-4 in March of 2023, followed by a lot of fierce competition from Anthropic, Google, Meta, as well as all of the open source models on Hugging Face. So suddenly everyone was building LLM powered applications. The use cases really seemed endless, right? Chatbots, coding copilots, document summarizers. We were really excited, and the promise of LLMs was massive. LLMs could write code, they can answer complex questions, they can help you plan your day in theory, but they have one kind of key limitation in that they're frozen in time. LLMs can only access information that they're trained on. If you ask ChatGPT-4, what's the weather today in New York City, it would say I don't have access to that real-time information. And they are passive. They can't break down complex tasks. They can't iteratively solve problems using tools. They're disconnected from the world. So they have no connection to email, book meetings, or call APIs natively. So while the promise of LLMs was there, the actual utility was pretty constrained. That brought us to 2024, where everyone started really embracing RAG and the rise of RAG. The idea, again, really simple: combine LLMs with external knowledge sources to keep them relevant without having to retrain the whole model. So vector databases exploded in popularity. The use cases were really compelling. You could do enterprise search, you could do chat over your documents, you could do intelligent customer support bots. And then prompt engineering and that kind of focus for LLMs really gave way to retrieval tuning and embedding optimization. Actually, I'm going to pause here really quickly. I'm getting a note from my team members. We're going to launch a poll to ask you guys some questions about how familiar you are with agents and MCP. So feel free to answer that when you have some time. Thanks. Sorry, Jess. Okay, going back to RAG. So everyone was really excited about RAG. RAG kind of became the go-to way to keep LLMs current and accurate. By the way, if you're interested in building RAG systems, which are super useful for things like enterprise search, check out our RAG webinar, where Kunling and I go through not only why RAG is valuable for certain use cases, but also how to solve the data pipeline problem that really bogs down a lot of RAG systems. So there's a QR code, or you can click the link to watch the webinar. We'll be sharing this presentation out in the chat and then also follow up via email, so you'll have access to this. But definitely check that out if you're curious and interested about implementing RAG. So like I said, RAG is great for a variety of use cases, but like LLMs, it also has limitations. Even though RAG solves the knowledge freshness problems that LLMs have, it's still limited by the knowledge base that you provide. It still can't, act the way that we would want an agent to act. And as I mentioned, the data pipeline complexity is pretty significant. Most information that you want to upload to a RAG model is unstructured, including text, audio, documents, emails, which requires a lot of compute processing and infrastructure. So again, plug for our RAG webinar if you're dealing with that issue. We go over it in detail and how to address that problem and solve it. But the biggest limitation, like I said about RAG, is that it's still fundamentally read-only. LLMs got better at consuming information, but they still couldn't act on it, which brings us to where we are today with 2025. A fundamental shift in the way that we think about kind of like LLMs in general. We don't want LLMs that can just read better. We want LLMs that can act, that can call APIs, that can automate tasks, that can perform multi-step reasoning. We don't want one-shot answers. We want autonomous workflows that can break down complex problems and solve them iteratively. That's why we call them Agentic AI. They're LLM-powered systems that can reason, act, and adapt towards a goal. Think of an agent as a system that can autonomously interpret your requests, plan how to achieve it, interact with external tools, and then make decisions based on requests, iterating until that goal is achieved. So a couple of examples that I have here, you could ask an agent, cancel my subscription and refund the last payment, right? That's going to involve calling a billing API, processing the refund, and updating a CRM. You could say, analyze your Q4 performance versus competitors. That involves not only pulling your financial data, but also searching for market reports, for competitor information, and then creating an analysis of all that. So it's a variety of kind of sources of information pulling together for one solution. And over time, agents themselves have evolved. So we started with very simple tool calling agents. And even in the past, I don't know, like weeks and months, we've seen more and more complex agentic systems evolving to operate in swarms, to thinking and orchestrating, and even working with other computing devices. So like we're at the point right now in 2025 where we were at with LLMs in 2022, where it's like the promise of agents is there and it's really exciting and there's so much power. But building these actual systems is where teams hit a wall. Because building production grade AI, agentic AI, sorry, is incredibly difficult for a variety of reasons, right? Tool integration is really brittle. Every API, every database, every script you want your agent to use needs custom JSON schema. It needs unique definitions, input output validation, you name it. That makes error handling very complex. And because it needs to work across a variety of LLM frameworks, whether you're using OpenAI, Anthropic, open source models, it doesn't really scale. It makes debugging really painful without standardization. It's really difficult to trace why an agent made a decision. And if something breaks, good luck figuring out, was it the tool call? Was it the LLM response? Was it the validation logic? Like, how do we find out? And then the last two kind of limitations of building production grade agentic AI is that existing frameworks are rigid and opinionated, which makes it really difficult to configure an agent exactly the way you want. And most infrastructure for agentic AI is very bespoke. So every team feels like they're reinventing the wheel, building custom orchestrators, validators, planners, memory modules. The existing frameworks work for demos, but they really break down when you get to multi-tool production systems, which is exactly what MCP was designed to solve. Okay, so before I pass it over to Kinling to talk in detail about kind of like an MCP demo for y'all, I wanted to cover really quickly, what is MCP? If agents give LLMs the power to act, MCP helps those agents work together more effectively. That's a good way to think about it. Because most real world tasks don't require a single action. So you usually need a sequence of coordinated steps that often involve multiple agents. So going back to the examples that we covered earlier, if you want to cancel my subscription and refund the last payment, there are multiple steps involved with doing that. The agent needs to call a billing API, it needs to process the refund, needs to update the CRM, right? If we want to analyze our Q4 performance versus competitors, you have one agent pulling internal financial data, another agent searching for market reports, and then a third agent creating a summary, and potentially a fourth agent creating visualizations. And this type of orchestration is really complicated, which is where MCP comes into play. So think of MCP as a shared language protocol that lets AI models, tools, and data communicate clearly and reliably. And it does this through four kind of standardizations that it implies. First, it helps create a shared context memory, so agents don't duplicate work or miss key information. It clarifies roles and responsibilities between agents, so each agent kind of knows what it's supposed to do. It standardizes tool descriptions and access, so agents are all accessing tools the same way. And it structures how agents pass information from one another, enabling smooth multi-step workflows. So I'm really excited. Kinling just got back. I'm going to hand it over to him for a quick history of MCP and then a dive into the actual demo. Kinling, over to you.
Thank you so much, Julia. Yeah, I would like to give a quick history of MCP. MCP is a fairly new concept. It was released last year in November by Anthropic. And after that, the major player in Gen AI have adopted, and the MCP community has rapidly evolving. Some of the big players, including OpenAI, Google, and Microsoft. And recently, Anyscale is also enable people to deploy MCP scalably in a production-ready way. And unfortunately, we don't have enough time today, but we will cover that in our July 22nd, 3rd webinar. Next. Yeah, so now I would like to show you how MCP works based on my personal experiences. This is MCP. This is the first agent I built um, over like 1 year ago. It's a research agent. When I first built this agent, there are no MCP available. So I built this agent in a old-fashioned way. So this research agent get question like what are the recent development of Gen AI? It will use a Google search API to get the recent news. And then the research agent will read the search result and generate the answer for that. After that, the agent will save the question and answer and upload to the Notion. So before MCP, um, what you need is that first you have to integrate Google Search API as a tool, and then similarly you have to integrate Notion API as a tool. And in addition to that, you have to implement custom code to parse and validate the input for each tool. And for different agents, you have to re-implement the same tools. And also later on, you want to add more tools, right? And then that would be really time consuming. And actually, most of my time spent is building newer tools rather than, enhancing the agent capability. So what happens if we have MCP now? Then we can just both integrate the Google Search and Notion API using the same protocol. You can also easily switch from Google to Bing Search or from Notion to other application. And any agent that supports MCP can do similar workflow. And also, because right now so many people contribute to MCP, you can leverage MCP that others have built. So it really makes the agent building process much easier. Um, Here, I would like to highlight the core components in the MCP architecture. So there are like three important components. One is the MCP host. This is the main application you use, like a a desktop app you are using, or it's an agent you are building. And then we have the MCP client. So MCP client usually sits inside the host. It's a part of the host. It acts like a bridge or connector that link MCP host to MCP servers. Um, Later, I will illustrate the concept, but keep in mind the client is not equal to host. Host is end application. The client is just a one small component. And MCP server is usually the lightweight program that specializes in accessing specific type of information. Those information could come from your local data source, like a local DB in your computer, or it could be calling remote API to get some information. Using Ray and Reserve, actually, you can wrap up a deep learning or machine learning model and the MCP server, which is more advanced usage. However, most of the MCP server you find online, they are just lightweight wrappers that access to certain APIs. Okay, next slide. First, I want to talk a little bit about MCP client. As we mentioned earlier, MCP client is a bridge connect MCP host and the MCP servers. It has two main functionality. One is to discover the available tools by calling this list tools function. And the number two, it will handle tool execution by using the call to function. Um, So think about it. If you have an agent, the agent need to know what kind of tools are available, and then the agent can decide it what tool to use. And also the agent can actually give the input parameter for that tool. So later on you can uh, connect the MCP client with MCP server to execute that tool. So that's how MCP client works. Next is the MCP server. Um, so MCP server also have several components. The most important one are tools. This is a required component. So those tools are actually functions that LLM can call and perform specific action. For example, that tool could be a specific weather API or it could be Google Search API. And the tool definition usually can include those three parts. Number one is the tool name. Number two is the tool description. Number three is the input schema for that tool. So with those three information, the LLM or agent, they can know like what tool to use for specific task, and also what are the inputs for the specific task. And also you can define resources or prompt in the MCP server. So resources is very similar to get endpoints in a REST API, where you can get some meta information about this MCP server, or you can also store some important prompts in the MCP server. But those two parts are optional. Okay, so this is how MCP server works. Now I would like to show an example workflow to integrate MCP with LLM and agent application. So this agent in this example is actually a GitHub agent. The user sending a request, summarize the five latest commits, and after that, the LL agent will actually uh, uh, the MCP agent, the agent, which we also call MCP host. Inside of that, we have the MCP client. The MCP client will communicate to MCP server and get all the available tools. And after we got the tools, and then that tool information, including what we talked earlier, the name, the description, the input schema, back to the MCP client. And the MCP client will pass to the MCP host. Next, please. And during next phase is tool execution. So after LLM get the prompt, get the tools, and then the LLM will decide which tool to use. In addition to the tool selection, the LLM will also generate the input schema for that tool. And then the MCP client will communicate back to the MCP server with specific tool to use and along with the input for that tool. And then the MCP server will get the results from the GitHub and return those results back to the MCP host, which is our agent. And finally, the agent will generate the response based on the results. Again, this is the simplified version for more advanced agent that can do planning, do orchestration. So this process is more iterative. Okay, next slide. In next part, I want to cover the MCP transport protocols. So MCP protocols, uh, for me, initially very like confusing, because again, it's not similar to HTTP. For example, for HTTP, usually the client and server, they have a clear separation. But in certain transport type of MCP, we will cover it later. We will see that the client and server, they actually have a tight one-to-one coupling. Next slide, please. So first, I want to talk about the first transport protocol, STDIO. It stands for Standard Input and Output. So using this mode, the client server, it actually has the very tight one-to-one coupling. What does it mean? So it means each client directly owns the server subprocess. If you look at the diagram on the right, this is from the Anthropic official documentation, you will see the client, it actually launched the server as the subprocess. And after the host and also the client exits, the child server process is terminated automatically. I think this is convenient for local use. For example, you are calling the MCP and then using Cloud or Cursor app. After that use of the MCP is done, then it will automatically clean up and shut down the MCP server. So you don't have to worry about it taking the computer resources. I think that's also the Anthropic trying to promote the MCP in a local way to interact with the cloud. That's a top app. Okay, next slide. Then later on, people asking, can we use MCP in a remote approach, right? Because you want to deploy MCP, in a server, and also the user can connect MCP locally, so they don't have to directly deploy the MCP. So MCP later on developed two transport modes. One is SSE, server sent events. One is streamable HTTP, which just released 2 months ago. So for server-side events, it had two endpoints, post messages and get SSE, but it only allow one-way communication from server to client. And also it's stateful by design. And it's very hard to scale more than two replicas unless you have to develop your own sticky session management. That's why SSE is being phased out and in a legacy mode. And the new transport type streamable HTTP address several limitations of the traditional SSE mode. Basically, use a unified endpoint slash MCP, and also it building session handling, resumable connections, and also it is compatible with SSE stream. And also you can enable at the stateless servers, so that make it much easier to scale. So the adoption of streamable HTTP are catching up. Next slide. And the other thing to mention is the MCP inspector. This is also developed by Anthropic team. So this is used for to validate and debug your MCP servers, but make sure you use a version which is larger than 0.12. That's going to support the streamable HTTP. Earlier version, they only support SSE and STDIO mode. Okay, next slide. Next, I want to show some demo to actually deploy MCP locally. For this demo, I already put the code in this GitHub link. It contains all the material we will go through today. So those three files I show you right now actually are three different transport types for the MCP server, STDIO, SSE, and streamable HTTP. They look very similar, but I want to highlight how easy to use MCP and wrap that function as a tool. As you can see, the core function is just a simple add function. By using the function name, the MCP automatically create a tool name using the function name, and also using the doc string that will become the tool description that allow the LLM or agent to understand which tool to use. And also based on the input types, the MCP will also automatically create an input schema and do the validation for that input for you. So you can just write the tool just how you write regular Python function. And you can easily swap the function into other API you want to add, right? Very, very convenient. And also you can run all those three files separately, but keep in mind because quirks of STDIO, if you run the script directly, nothing will happen. You will feel like your program gets stuck. Because again, you can't just run the stdio script alone. You need a client to set up as a subprocess, which we will talk about later how to do that. But for the other two types, you can directly run the script, and then that will initialize a URL, local URL for you, and then later on you can connect with the either MCP host or MCP inspector. Okay, next slide. This is a code to use the MCP client. On this example, we show you how to support those three different transport types. And if you look at how we connect to stdio mode, you will see actually we are passing the server script at the input. And inside the code, it will actually launch the server at the MCP server as a sub-process. And then the MCP client will actually connect to the server and get all the tools here. And in the code later, which is not captured by the screen, this script also show how to handle tool calling and to execution. Okay, next slide. And this is how you test MCP locally with MCP inspector in standard IO mode. Um, when you use the standard IO mode, you have to select the transport type as TDIO and then command. We are using UV. UV, you can actually directly run the script. And in the arguments, you put the script path in it. And then the MCP inspector is actually a MCP host. And internally, it has the MCP client that will start the server using the script as a subprocess. It will establish a client-to-server one-to-one relationship. Um, Again, one-to-one means it does not support other like client to communicate with that server. Only this MCP host and the client is able to communicate with this MC server. That's why it looks strange to me in the first why we have to pass a script, when we're using the standard IO mode. But if you look deeper in the architecture, then this explained it. Okay, next slide. And this is how you test MCP locally in SSE mode. You can directly pass the URL for the SSE, but don't forget to add that /SSE to your endpoint. And in order to test it, of course, you have to run the server script first in your terminal. And then the MCP inspector connects the MCP server using this URL you entered. And in this approach, you can actually support remote MCP. But again, this is very hard to scale because it's stateful by design. So unless you implement some sticky session manager, it is very hard to scale. Next slide. Then this example, very similar to SSE, you just enter the URL with /MCP, and then the MCP connect the server via the URL. And again, this is support remote MCP. Because you can enable this as a stateless mode, that's why it's easier to do auto scaling. Okay, next. And here I also include some example to actually deploy the MCP server with MCP Docker image. As we all know, MCP is a very vibrant community and people contribute MCP server. They usually wrap up at the MCP Docker image. So this example actually use the MCP called fetch MCP. It's able to extract the web content given the URL. And very similarly to the UV command, here we use Docker to directly run the Docker container and launch it as the Docker container process. And it will establish a one-to-one relationship, and it will automatically remove the container file system after the MCP host or the client exits using the --arm command. Okay, next. And for people who are interested in building your own MCP Docker image, I also include that in the tutorial. This is actually completes the official weather MCP server tutorial by Anthropic. In that tutorial, it just show you how to build the MCP server but didn't show you how to wrap up that MCP server in the Docker image. Using the Docker image, you can containerize the dependency. It makes you very easy to share to the community. For more MCP Docker image, you can go to this URL to look at the other Docker image you want to use. But keep in mind, most of the Docker MCP images are in the stdio mode, which is, again, very hard to scale. But in our next webinar, we will tackle some of the issues, how to scale with Docker image in stdio mode using Reserve. Okay, next one. In next section, I want to show you how to integrate MCP with local apps. Um, and I know a lot of people are using either LLM app or agent app locally, and integrating MCP is really easy, and also it's gonna make your life easier. So we want to work through two examples how to integrate MCP with local apps. Next slide. The first example is use MCP with Cloud Desktop app. So I put the detailed guide in that link within the same GitHub repo. And this is example, it's actually using the weather API, weather MCP. So in this example, after you set up the MCP server, either given the Docker image or using the UV, and then you can set up some configuration file for the cloud desktop to load those MCP. And after that, in the app, you will see there are additional option for you to actually enable the MCP by either introducing the tools, or you can disable the tools if you don't want to use those tools. Because each MCP server usually have two or more tools, so the desktop app actually allow you to select which tool you want to use. On the right side, this is the example in action. The user asking what is the weather like in Palo Alto. Actually the cloud now is able to generate the input for that specific MCP tool to get the forecast with the latitude and longitude converted from the Palo Alto location. And then after it getting the response from the API, it will generate the final response using that information they retrieved. Next slide. Similarly, you can connect MCP with Cursor app, and you can use the same MCP config as the cloud desktop app. And after that, on the cloud, you can also ask a question. It will give you similar responses. Again, this is very, simple demo, but you can integrate, for example, with the GitHub MCP. And then you can interact with the cursor agent that allow you to push the code to do the PR and also automate the Git workflow for you. Okay, next one. Um, yeah, so here we want to show what are the next steps in the webinar. Um, Before I hand over to Julia, I want to highlight some of the LLM and agentic offering we have at Anyscale. So at Anyscale, we actually have several core products. If you are interested in LLM and the agentic world, the first one is LLM serving. Then we have LLM batch inferencing. If you want to process a large volume of data, we can leverage Ray data to do the scalable unstructured data processing. And also at any scale, you can build your own end-to-end LLM agent. And also we provide you the platform to do LLM and agentic fine-tuning and post-training. And, recently we launched the MCP server deployment using Reserve and the Anyscale services, and we will cover more detail in our July 23rd webinar. Okay, I'll hand over to you, Julia.
Thanks, Kunling. Okay, so yeah, as Kunling mentioned, we have a follow-up webinar to this on July 23rd. So please join us for Agentic AI in practice, where we're going to talk about actually building scalable and production-ready MCP servers. We're going to cover specific deployment architectures for multi-service MCP setups and show you actually like real-world demos on how to deploy it. Kunling covered a lot of like local deployments in this webinar, and it'll be like more real-world in the one on the 23rd. So the registration page is up. We'd love to see you guys there. Please join us if you can. Last but not least, a couple of things. So this deck will be shared out to you. We're going to add it in the chat in a minute, and we're also going to share it via email after this call. We have a link to a ton of resources that you're welcome to check out. Again, plug for that RAG webinar that we did if you're interested in that. And a couple of next steps before we get into Q&A. If anyone is interested in trying AnyScale, you can check out the website now for $100 of free credits. In the webinar that we do on the 23rd, we are going to be using the AnyScale platform. So make sure you get access ahead of time so that you can follow along if you're curious and interested in doing that. We also offer more in-depth hands-on training if you want you and your team to be able to kind of get training on Ray or AnyScale or anything in between. And if you have any questions that we are unable to answer in this call, please consider joining the Ray Slack community. It's where practitioners in all sorts of AI and ML share tips, tricks, ask questions. Of course, we are going to do a Q&A for the next couple of like 20 minutes, but I'm not sure we'll get, there's so many good questions. I'm not sure we'll get to them all. So if your question is not answered or if you have any follow-ups, consider joining that Slack. So for Q&A, I'm also going to invite Akshay to join us. He's been answering some of your questions via text, and he's going to join Kunling to answer them live. And then again, quick plug, don't forget to register for the hands-on lab on the 23rd. Over to you, Akshay.
Okay, I see a lot of good questions come in. So, Kunling, the first one is, how does MCP handle security and async communications?
That's a great question. So actually, MCP right now is evolving very rapidly. And in the past few months, MCP has another set of new design come out that will specifically handle the security and async communication. So we will cover some of the topic in our next webinar for that. Yeah, again, MCP is evolving so rapidly. And in the previous MCP's design, internally, you can handle security, but right now with the new design came up, you can actually integrate some of the security, do that. But if you don't want to handle security, you can also consider using any skill service. For example, after you deploy MCP, using any skill service, it will automatically generate the authorization token for you using bearer token. So that will make the whole deployment process much easier.
Okay, there's a lot of questions about A2A and MCP. So can you comment on those? What is the difference? How do they work together?
Yeah, for people don't know A2A represent agent to agent protocol. It's very similar to MCP in high level design. For example, for MCP, you have the tool name, tool description, the input schema for that tool, right? Similarly, for A2A protocol, you can have, agent name, the agent description, like what is the input output for that agent. I would say it's a similar fashion, and I believe using reserve is a natural, fit for both MCP and A2A. In the future, we will probably have, some webinar talking about the A2A and also more advanced agentic or a multi-agentic system.
Yeah. Cool. Thanks. And then there is another question on, in the context of integrating custom functions with LLMs, what underlying mechanisms or signals enable the model to recognize when a particular function should be used? So it's basically talking about like the OpenAI API. So Kunling, can you tell us a little bit about that?
Yeah. So the underlying signal is actually based on again, two name, two description, and two schema. For example, if your two name and description they conflicting with each other, just give you example, it's supposed to be the two name at least git commit, but actually it's doing the PR in the git. That will confuse the model, right? Or you have two tools that have the same name, but different description, or vice versa, have different name but same description. That will confuse the large language model to understand, okay, which tool to use. And similarly, the input also matter. That will give some small hints for our model to, understand what kind of two parameter the large language model should be generating. And this is a little bit hard to scale if you have, for example, hundreds of tools, right? In that situation, you may consider to break up the tools or functionality into multiple agents. So each agent is handling specific set of tools or actions. So that will make your design much cleaner. I do see some people when they design the agent, they're struggling to let the agent to select the right tool. And also you have to consider using some of the most advanced large language model. If you're just using very small or low quality large language model, sometimes they will struggling. And again, even you are using the most advanced large language model, sometimes it will fail. In that case, you may consider first improve the prompt in your agent. Number two, if that doesn't work, you can consider to fine tuning the large language model for your agent system.
Cool. There's a question on if we're looking to build an MCP server in a language other than Python, is that supported essentially, and is the input schema described in a certain way? And similarly, is the output of a tool always assumed to be unstructured and needs an LLM to interpret, or can it be structured?
Great question. So for MCP, when you build MCP server, you can use all various language. So for me, I know Python, right? So I build MCP with Python, but the official MCP library, they also support other language like Node.js. I saw that as a very popular one. And also, those experiences are very similar. No matter you are using Python, Node.js, you just define the function, and also you don't have to specifically, write any input schema for the MCP. You can just write the function as you usually write in Node.js or Python. But you may have to go through the tweak interacting with the large language model to see if the large language model can actually understand your description, understand your tool name, and also generating the correct input schema for you. But that's the beauty of using MCP. MCP does it automatically for you, this kind of wrapper work. And also for the output, it does not need to be unstructured. It can be structured as well. And also, the other trick to mention is that in your own function, you can also do some filtering. For example, when I use Google Search API, it gives you like 20 different fields. Let's say it's 20 different fields, but I only care like two fields, the URL and also the text snippet from the Google search. So in my function, I actually did a little bit cleaning up and the filtering to only keep those data after calling the Google Search API. So using MCP make it extremely flexible and easy for you to integrate with the other API and services.
All right, there's a question on when using MCP servers, can we have a dynamic description? For example, schema of table while declaring a tool. I believe that's not possible today. The description has to be static. But as Kunling said, like the MCP protocol is uh, like very fresh still, and I'm sure it's continuously evolving. So you should also feel free to create issues with their GitHub repo to ask for these types of enhancements. All right, here's some like more questions based on your experience, Kunling. What custom MCP tools have you used in the past to improve your development quality of life or efficiency?
Okay, that's a good question. So for me, I like the Notion API too because as we all know, the agent world is evolving rapidly. For me, I have to catch up with all the newest information and also to learn all the new papers or tools or library come up. So personally, I use a lot on the Notion API. And also, I think I really like the local file system API developed by MCP. So using that MCP, it's not the API, sorry. Using that MCP, it allows the agent to, for example, create a folder, create a file, and also edit the file for you. For example, if you have a Python script using that local file system MCP, it will actually change certain line in that file rather than regenerating the whole Python script for you. So that is really make my life easier. And also, actually, I developed another agent demo that actually using this local file system that agent just like a data scientist or machine learning engineer by connecting with Ray Power, for example, it can launch a Ray worker node with CPU and GPU and generating Python script, execute the code, and also doing machine learning, modeling, training, writing the reports, generating the plots. So it's really powerful to use those MCP. Without it, I probably have to spend weeks to write my own MCP to allow the agent to do that.
What are some of the use cases you've had of agents? Any particularly anything to modernize existing systems or yeah, can you give some examples of agents that you've developed in the past?
Oh, yes. So for agent, as Julia showed earlier, also agent developing quickly. Initially, we have two calling agent, then we have React agent, reasoning, action, and now we are moving to multi-agent system as well. Agent with compute device. I think agent with compute device is definitely, one of the biggest trend. You all heard the hypes from, Manus. Um, and also recently the cloud released like a local coding agent cloud code and also Gemini CLI. They allow the agent actually interact with your computer directly and then to either execute some command, generating file, do all sorts of things. So in my opinion, the agent in the future, they will actually do more and more complex and end-to-end task for you rather than just answer question, gather some information. Even right now, most of the agent I saw is just a simple tool calling or connecting with some API services, do some research. But to allow the agent to actually control the compute device, it could be your phone, could be your computer, or using Ray, it actually can control the Ray cluster for you that may scale up with 100 CPU or GPU. So I believe that going to be the future of MCP because if you look at the progression of the agent or AI in general, it starts with very simple tasks like image classification, entity recognition. Now the agent can do more and more complicated work like doing research, and writing code for you. But in the future, the agent, for example, can develop end-to-end application or building an end-to-end machine learning project for you. So as a human, you just need to become the judge and judge the work for them. So that's what I saw the agent development.
Cool. Um, there's one question on my org wants to create MCP tools that are only available with the organization, not exposed to the public. Is this a good use case for MCP? What is your advice? So I believe here, like kind of all the standard service discovery type of things still apply, like if you use API gateways to control authorization or access or like private subnet, private networking, VPC peering. So all of those should still apply, and MCP is kind of more the interaction protocol. Anything else to add, Kunle?
Yes. For this, in next webinar, we will also cover how to build your customized MCP using Reserve. One example I have, for example, you already have a machine learning or deep learning model. You want to wrap up at the MCP, and also you want to add on authentication and the other stuff. So using Reserve and AnyScale service will make it so much easier. Otherwise, you have to use Kubernetes, write in tons of configuration file. And even before using Kubernetes, you have to write your own Python code because again, the MCP design client and server, they don't have a clear separation. It's not like a web server in nature. The like tight coupling of the client server relationship is make it really difficult for you to scale and add additional security. That's how Reserve and AnyScale service is going to help you to deploy, production ready MCP.
Cool. I think that's most of the questions that we have here today. And we'll answer some of the other ones offline.
Awesome. Thank you so much, everyone, for joining. To answer a couple of the questions that I see coming in the Q&A and in the chat, yes, this recording will be shared out as well as the deck via email following either today or tomorrow. So stay tuned for that. And then again, if you're interested in trying AnyScale, which we will be demoing as well in that July 23rd webinar, please go anyscale.com right now and you can get $100 of free credits to try deploying your own stuff and see how it works. Alrighty. Thank you so much. I hope to see you on the 23rd. Have a great rest of your day. Happy Wednesday, everyone.
Thank you. Bye-bye.
Bye.